Okay, so don't quite remember where I left off in my first part of this example, but let me kind of come back here. I might overlap a little bit with part one, but now that we've set up our three equations, we've decided now we want to use the Gaussian elimination method to be able to combine equations one and two in such a way that their x's are going to cancel out. So if I multiply through by -5 in equation 1 and add that to equation 2, I'll have -5x plus 5x is 0. I'll have -5y plus 9y is 4y. And I'll have -5z plus 16z is 11z. I'll also have -250,000 plus 400,000 is equal to 150,000. So I end up with my second equation. Now, my third equation. Again, I need to combine equation 3, x minus 3z equals 0, with equation 1 in some way such that I eliminate the x's first. So I multiplied through by -1 in equation 1. And now if I add that to equation 3, -1x plus x is 0. -1y plus -3z is -1y plus no y is equal to -1y. -z plus -3z is -4z. And -50,000 plus 0 is -50,000. So that's where I got my new equation 3. Now I have one more step to my Gaussian method of elimination, and that is to do something to combine equation 2 with equation 3 such that I eliminate the y in equation 3. Well, if I multiplied equation 3 by -4 and add it to equation 2, if I multiply everything in equation 3 by +4 and add it to equation 2, I'll have 4y plus -4y is 0. I'll have 11z plus -16z is -5z. And I'll have 150,000 plus -200,000 is -50,000. Okay, so I eliminated the y's, and then all I decided to do was just flip-flop so that I had, okay, to be honest with you, I don't know why I decided to write it in the way that I did after computing what we just described to get -5z is equal to -50,000. But I decided to use it to replace equation 2 as opposed to equation 3, and either can be done. So I put the -5z equals -50,000 in as a replacement for equation 2, and I left equation 3 as is. For the life of me, I can't remember why I decided to do it that way, but it can work this way as well. So the -5z equals -50,000 replaced equation 2, and equation 3 stayed as is. Then I just decided, okay, to make this triangular, I'm going to flip-flop equations 2 and 3. And I'm going to simplify them as much as I possibly can. So equation 2, I could divide by -5 on both sides, which is the same as multiplying by -1/5. And that's where I got the z is equal to 10,000. And in equation 3, so I didn't have so many negative terms to work with, I decided to multiply through by -1, which is perfectly fine as long as I do it to everything on both sides of the equal sign. So -1y, -1 times -y is y, -1 times -4z is 4z, and -1 times -50,000 is 50,000. And then, as I said, I just flip-flopped equations 2 and 3. Phew, the puzzle is almost solved. So now I'm going to do the back substitution. I need to substitute 10,000 into equation 2. So I'll have y plus 4 times 10,000 is 40,000 is equal to 50,000. Therefore, y would equal 50,000 minus 40,000, which is also 10,000. So now I know Y and Z are each $10,000. So now I have to determine how much is invested in X. So X plus Y plus Z is 50,000. That means X plus 10,000 plus 10,000 is 50,000. That means X plus 20,000 is 50,000, which means the remaining 30,000, which we know is 3 times what we invested in the high-tech fund. 3 times 10,000 is 30,000. 30,000 will be invested in X. To check, I will be able to go back and say, okay, let's check equation. Let's go to the original just to be sure we haven't made a mistake along the way. Okay, well, or the move the decimal point version. So 30,000 plus 10,000 plus 10,000 add up to 50,000. In equation 2, 5 times 30,000 plus 9 times 10,000 plus 16 times 10,000 does equal 400,000. And 3, 30,000 minus 3 times 10,000 does equal 0. So I now know that what he needed to invest in the money market account, X, is $30,000. In the blue chip stock fund, Y, is $10,000. And in the high tech stock fund, Z, is $10,000. Let me know if you have any questions.